Okay, we continue with chapter 5.3, compound interest compounded continuously, right? So we have seen compound interest in which interest is compounded yearly. We have where M is equal to 1. We have seen cases where interest is compounded semi-annually, meaning M equals 2. All right, that means interest is calculated 2 times a year for all the number of years in which the investment or the loan is for. And the M interest compounded quarterly, meaning M equals 4, monthly, weekly, and daily. All right. So now, what happens when M becomes very large? That's what happens when interest is now calculated like every second or every hour. So you can imagine how many seconds there are in 10 years. That's a lot. That's a huge number, right? So when M becomes that very, very big, as large as that, what then, how then do we handle it? So this is where continuous interest then comes in. All right. So continuous interest then comes in to help us handle interest calculations in which M is interest is calculated non-stop. Interest is calculated continuously. So every second or every millisecond of the day, interest is being calculated for all the number of years. All right. Uh, um, that the loan or the investment is for. Right, so that is where, so we usually indicate continuous interest by, for instance, 6% per year compounded continuously. All right, so when you see a question in which they say 6 or 5% per year compounded continuously, then you know that we are referring to continuous interest. So you then refer to the continuous interest formulas for your calculations. Okay, so the only difference is that continuous interest is in continuous interest, this part of the formula, all right, which is in compound interest. Remember that the future value for a compound interest formula S is given by P times 1 plus R over M, all right, to the M n. Okay, so this part of it, with the M, that part there, okay, is then replaced with the expression e to the r. Okay, so we then use this exponential expression to approximate or to measure the interest calculations where in situations where M is very, very large and extremely big to handle using the usual simple compound interest formula. All right. So recall e to the r is the same e to the x function that we looked at in our last few chapters. I think chapter 4, we saw exponential and log functions. So this is the same e I am talking about, right? It's the same e, the same exponential function we are referring to. So in that note then, S is then given by that expression there. So S is equal to P times E to the Rn, right? Where S is the future value, P is the present value, R is the rate of interest, and N is the number of years. All right. So you realize that in this case, we don't have M because our M has then been replaced with the exponential term there, the exponential part expression there has then been used to approximate our M. Okay, so that is the formula for interest compounded continuously. So then if we are to summarize the compound, the interest formulas, then we remember that for simple interest, it's given by that. Then for compound interest with effective interest rate, okay, recall that effective interest simply means interest where interest compounded annually, right? So once you see compounded yearly or compounded annually, where interest is calculated only once a year, in this case where M is equal to 1, it's the same thing as saying effective interest rate, right? I'm saying this because in some questions, you will not be told that interest is compounded yearly. You will just be told that interest is calculated, interest is given by 6% effective interest rate, all right? At 6% or 7% effective interest rate. So once you see that effective interest, just know that they are talking about interest compounded annually. All right. So otherwise, it is a nominal interest rate where M is either quarterly or semi-annually or yearly or weekly. I'm sorry, not yearly, or weekly or daily. Okay. And then so in that case, for nominal interest, the formula is then given by that. Okay. And for continuous interest, where M is compounded continuously, all right, you will be told in the question that the interest is 7% per year compounded continuously. Once you see the word continuously, you think of that formula over there. Once you see the word effective, you think of compounded annually. Once you see the word continuously, you think of this. Once you see compounded quarterly or semi-annually or at a nominal rate of blah, 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 then you think of this other formula over here. Right, so don't get confused between the formulas. Okay, let's look at a very important part of this section, which is comparing interest rates. Okay, so this is absolutely important because if you are a banker, for instance, and a customer walks up to you and probably he or she has been given options, investment or loan options, all right? Let's say the person has the option to invest some money at 5% per year compounded semi-annually or 3% per year compounded quarterly, and they are confused, all right, which one to choose, which one will be a better investment option, okay? And then they come to ask you that question, then this is where you then employ your knowledge of comparing interest rates, right? So you then use any of the formulas below that we are going to see explicitly very shortly to see how to compare these interest rates and advise your customer on which investment option to choose. Okay, now when comparing interest rates, note that when you are making an investment, you choose the investment with a higher interest rate because when you invest, interest is paid to you, all right? But when you are taking up a loan, you choose the one with a lower interest rate because when you loan money, you pay the interest instead. Okay, so questions usually arise like, for instance, a person wants to invest money at this options A, B, or C interest rates. Which one should the person choose? Or a person wants to take up a loan and they are given these three options at the bank, which one should the person choose? So you should have it in mind that if it's an investment, then you are choosing the option that has the highest effective interest rate. And if it's a loan, you are choosing the option that has the lowest effective interest rate. Okay. So then every time interest rates are being compared, you convert all the given interest rates to effective interest rates. You cannot compare interest rates while they are nominal or in continuous rates. Okay, you can only compare when their compoundings are the same, and that's only when they are in effective interest rates, when they are in their effective interest rate forms. Then you know that M is equal to 1 in each of these cases. You can then be able to compare them. Okay, so in order to compare interest rates, the first thing to do is to convert each of the interest rates to effective interest, their corresponding effective interest. Then you see which one is higher, which one is lower. You see which one to choose depending on whether you are making an investment or you are taking up a loan. So this first formula here is the formula for converting from a nominal to an effective interest. Okay, so if you are given interest compounded quarterly or semi-annually or daily or weekly, then you can substitute that into this. So this is RNOM. RNOM stands for the nominal interest that you are given with a certain compounding M. All right. If you substitute that there and put everything into your calculator, you will get the corresponding R effective. Okay. Now, if you are given some continuous interest for you to then compare, then you can use this second formula down there to, first of all, convert your effective interest rate to your continuous interest rate, sorry, to effective interest. Then you can then compare. All right. And that last formula is then to convert from continuous to nominal. To convert from continuous to nominal. So let us probably look at, so this is just to take note that if money is being invested, we always choose the highest effective rate. Okay, highest effective rate. So which means the first thing to do is to convert all the interest rates to effective. Okay, then you choose the highest effective if money is being invested. And if we are making a debt like a loan, then we choose the lowest effective rate. That just naturally makes sense. Okay. Now, note also that when we compare investments, we always choose the investments with the highest future value. All right. So a situation could arise in which you are not comparing interest rate, but you are comparing investment. For instance, a person could be given the options of investing 6,000 at 6% compounded semi-annually, or investing 5,000 at 7% compounded quarterly, for instance. Then you are asked, which of the options should this person choose? Okay, then in this case, you are not comparing the interest rates because the principal amounts are different. So all you need to do in this situation is to find the future value of each of these investments. So you then use your S equals P times 1 plus R over M to the Mn. All right. You substitute everything, the principal amount, the rate, and the compoundings, and the number of years, and you see the future value of each. So the one with the highest future value is definitely the one that this person should choose. It's definitely the preferable option for the customer. Okay, let us look at a few examples of these before we go. So this example says an investor has a choice of investing money at 6% compounded daily or 6 1/8% compounded quarterly. Which is the better choice? Okay, which is the better choice? So the investor has a choice of choosing between investing at 6% compound. Now, looking at it at first glance, you cannot immediately tell which one to choose. All right. You can't immediately tell which one to choose unless you convert these nominal interest rates to effective interest rates. Then you can see which one has the highest effective interest, and then you can conclude which is the better choice. So if we convert 6%, so we are using that first formula in our set of formulas above there, and we are trying to convert 6% now to effective interest. So if you substitute the nominal interest of 6%, everything there, and it's compounded daily, so my M is 365, right? Minus 1, then you get a rate of 6.18%, and you use the same formula to convert 6.1 over 6 1/8% compounded quarterly, right? So it's quarterly, so my M is 4 in this case. substitute everything there, the nominal interest of 6.618%, then you get a 6.27%. All right. So the 6.18% compounded quarterly is a better choice for investment because it's got a higher effective interest rate. It's got a higher effective interest rate. Okay, thank you.